see that it's 4:30, so I'm going to go ahead and get started. I'd like to first welcome everybody to the Forward in Energy Forum. We appreciate you all joining us here today in the room and online. My name is Lulu Fragoso. I'm one of the Education Outreach Assistants at the Wisconsin Energy Institute at UW-Madison. Welcome to those of you who are returning forum attendees, and if this is your first time joining us for one of our events, we're really glad you're here. The Wisconsin Energy Institute's mission is to provide leadership on campus for multidisciplinary research, education, and outreach efforts that accelerate our transition to clean energy systems and solutions. The Forward in Energy Forum is a monthly series that brings together experts both on and off campus for cross-disciplinary dialogue, exploring important technical, social, political, and economic dimensions of a wide variety of clean energy innovations and topics. Today's forum on commercializing fusion energy falls within two important celebrations. This week is National Clean Energy Week, which Governor Evers recognized in a proclamation earlier this week. This event is also part of UW-Madison's Innovate Week. There's a great lineup of talks, panels, webinars, and networking happening throughout the week with inspiring stories and practical tools for turning your idea into impact. I encourage you to go to innovate.wisc.edu to find the full list of events. Before we get into today's session, I have a few more announcements. First, we want to acknowledge that the land that WEI occupies, as well as all of UW-Madison, is the ancestral home of the Ho-Chunk people, who have called this land Dejop since land immemorial. We recognize and respect the inherent sovereignty of the Ho-Chunk Nation and the other 11 Native nations within the boundaries of what we now call Wisconsin. Please take time to learn more about and support the efforts of tribal nations in Wisconsin and beyond, who are leading the transition toward clean energy and just systems. Next, we would like for you to save the date for our next Forward in Energy Forum on October 15th, Latina Energy Leaders Tackling the Climate Crisis and Environmental Injustice in Wisconsin. We've got an outstanding panel lined up, and we're really excited about it. Finally, a couple of logistical notes. We'll have opening remarks from our panelists and some Q&A with our moderator before taking audience questions. Please submit your questions in the Q&A box. Finally, if you need live captioning, you can toggle that feature by clicking on Show Captions button in Zoom. If you have any other technical concerns, please let us know in the chat. To moderate today's panel, I am pleased to introduce Dr. Adele Wright. Dr. Wright is an assistant professor in the Department of Nuclear Engineering and Engineering Physics here on campus. Prior to UW, she was a staff research physician at the Princeton Plasma Physics Laboratories Theory Department in Princeton, New Jersey. Her highly interdisciplinary research focuses on understanding and predicting the macroscopic properties of magnetically confirmed plasmas. Dr. Wright also has expertise in science diplomacy and the intersection of science and policy. We are very grateful to have her with us to set the stage for today's discussion. Thanks, Adele.
All right, so thank you very much for inviting me here today. I'm really excited to be part of this panel. Let me just scooch over. So firstly, just a second. What? All right. It wouldn't be a hybrid event otherwise. Okay, so let's try again. So thank you very much for inviting me to be here. I'm really excited to be joined by such a wonderful panel of guests. We have Dominic Bindel from Real to Fusion. We have Professor Steffi Deem over at the other end there from UW-Madison. We have Chris Hegner, who's here wearing his Type 1 Energy hat, and Eli Moll from Shine Technologies. So you'll hear plenty more from them in a little while. But first, let me just say a couple of things just to make sure, we all get on the same page about, how exciting fusion is and why we're all here to hear some more about it. So as most people might be aware, fusion, as the name suggests, is what happens when two atoms collide and fuse together. It's one of the most energetic processes in the known universe, and indeed, it's the thing which powers the sun and many of the stars. So it seems like if we look up at the sun, it's shining most days. It's important to sort of think about why we happen to why this happens to be the case. Because if we could harness all of that energy and bring it right here down to earth with us, it would be really wonderful. And I think we'll hear about some new and exciting ideas for how to do that shortly. So, the real question of why the sun burns, but we have such a hard time recreating fusion reactions here on Earth, is because of the scale of things. So, if you imagine taking the sun and trying to fit it into a tiny, tiny box, maybe somewhere out in the middle of Wisconsin, then the challenges are quite extreme. So, in order to shrink something that's that big down to something that's a manageable size, we need to really increase the temperature of the things, the collisions in the things, and the pressures. And so these are the kind of considerations that create the environment in which fusion reactions are very plentiful, and in fact, enough that we can start to harness them as a useful power source. So that's going to be the thing that we're going to be talking about today. But because it's the UW Innovate Week, we're going to hear about this from the perspective of a kind of growing group of stakeholders in the fusion community, and that is the now burgeoning private sector. So we have representatives here who work in a bunch of different aspects of the fusion startup sector. And so we'll hear a little bit about their journey and their experience as part of this Innovate Week discussion. So before I kind of kick it over to the rest of our panelists, I'd like to invite Professor Deem to also share her perspective on this very exciting time.
Okay, thank you so much. And thank you all for joining us today. So my name is Steffi Deem. I'm a professor in the University of Wisconsin-Madison in the Nuclear Engineering and Engineering Physics Department. And I'm going to tell you a little bit about my journey because my journey to fusion energy was purely by accident. I'm originally from Southeast Wisconsin, specifically Racine, Wisconsin. I was a curious kid. I loved math, art, and science. And many of my family members actually worked in manufacturing. In high school, I worked on generators too. Yeah, and I didn't really know any engineers or scientists, but I was really curious to the point that my teacher and my dad really pushed me to look at engineering because you could get a great job. And also, they thought it would be really suited to what I was interested in. And even though I didn't know, I had never met an engineer or scientist, I just kind of jumped in. And I came to UW Madison and I was like looking around campus for jobs second day of class in undergrad. And I just accidentally fell into a position, an undergrad position in fusion energy. And it was pretty fantastic when they talked about how you're trying to use technology to harness the power of the sun, like Professor Wright said. The way it was described to me is how we're trying to confine the hot fuel for fusion with magnets is kind of like a challenge of confining jelly with rubber bands. I'm like, I don't know what that means, but that sounds like pretty interesting and you can help change the world. So I kind of like jumped in, went to grad school, and I was really hooked from there. I worked in the national lab scene on fusion energy and worked around the world. And then I came back to UW Madison about 4 years ago because of the history that we have in this field that's so transformative. So now I'm a professor at UW Madison, and I was appointed as a US Science Envoy in 2024 by the Department of State. So I do that as well. I'm going to tell you a little bit about the research that I do at UW Madison. My research groups work on really two things. Innovative plasma initiation technology. So our fuel is so hot, it's actually in the plasma state of matter, where you kind of heat up a gas so hot that you strip the electrons from the nuclei. So it's like an electrically charged material. So we work on how do you start up new startup technology for how do we start up future fusion power plants. And then the second research group is really looking at the intersection of society and technology when it comes to the deployment of fusion energy. So as Adele mentioned, we have to be very clever here on Earth on how we're creating the conditions for fusion. And so we have to heat up matter 10 times hotter than the sun to reach those fusion conditions. And so what we do is really engineering at the extreme. So we need to make our own magnetic bottles here. And so in the nuclear engineering and engineering physics department, actually just right across the street in the basement, is an experiment that my group built. Actually took us 3.5 years to build. It's called Pegasus 3. It was funded by the Department of Energy. And the technology that we developed really looks at starting up our device with something that looks kind of like a lightsaber. It makes these, they're compact injectors. They make these ribbons of plasma that really we capture with the magnetic field. And it works really well. And we hope that our technology could someday replace what's done now by large superconducting magnet technology. And that really speaks to the innovation and drive that we do here at UW-Madison. The second research group that I have is called the Just Fusion Collaborative. It was actually funded by Wisconsin Alumni Research Foundation. They're really looking forward, WARF is the organization, forward thinking about what can we seed that's done at UW-Madison by researchers here that could impact communities in Wisconsin. So they funded this research collaborative, and it's an interdisciplinary group that really looks at the intersection of the fusion technology, society, the environment, and economics. And we work with communities in Wisconsin and faculty and researchers throughout the campus too. And we really go and we center Wisconsin community members' voices. And we ask them kind of what values they have as a community and how that can be used to inform the design of fusion systems. And then kind of what hopes and concerns that they have so that we can make sure that we bring this into the design of fusion systems. We've seen a lot of excitement from community members just in the short amount of time that we've been doing this work. So I'm excited to watch that grow. We've also seen historic growth in public and private partnerships that really realize commercial fusion energy as we support this historic right now moment in time where we're working on transitioning from really studying the science of fusion to actually commercialization and application of that. What's fascinating too is a lot of the private companies have come from the work of universities. So about 60% of fusion startups actually come from universities in the US. And as of this is 2022 numbers, about 95% of, at that time, over $5 billion of invested in private startups went to universities. And we're really a powerhouse in Wisconsin, specifically the University of Wisconsin-Madison, because we have 3 companies here that really came and spun out of our institution, which was it's really unique actually for our field. And it really speaks to the urgent need that we have for long-term solutions to climate change. I also want to mention too that we talk a lot about fusion being the potential to provide like clean electricity, but it also can be a source of thermal energy and power for hydrogen production, industrial heat, carbon capture, desalination. So a lot of impact that can come from that. And then a lot of what we're doing now too was really spun out from the White House, launched in 2022, a bold decadal vision for fusion, which really challenged the community with the drive and really the desire to design fusion pilot plants that can demonstrate electricity generation in 10 years. And from that, they launched a milestone-based program where they're partnering with private companies. And we had 2 out of those 8 companies that were chosen were spun out of Wisconsin, which is pretty historic as well. And so I think I want to kind of close with this to really speak of like how we're going to deploy fusion globally. We have to think internationally from the beginning. And a lot of what we're doing right now in the US is building international partnerships that are really centered on kind of 5 things: identifying and pursuing opportunities for international cooperation in fusion research and development. Second is growing the future global fusion marketplace. The third is coordinating regulatory frameworks that create a secure environment for fusion. The fourth is fostering and strengthening a diverse and global workforce. And the fifth is improving public education and engagement in fusion energy. And so part of what the work I do as a US science envoy is kind of fostering that international collaboration and working kind of globally. So I'm going to turn it over to the companies because I think we have the potential for fusion is huge, and it's really exciting to hear from them on what they're working on. So thank you so much for joining us.
All right, thank you. Who would like to go first?
Okay.
All right,
Our,
you're
our
up.
approach, our approach is a little bit odd. Yeah, I'm Eli from Shine Technologies. Like I said, our approach to fusion is a little bit odd compared to what you're going to hear from Type 1 and from Rialta. Our approach has historically been a very scalable approach, the belief that we need to use fusion to form commercially viable opportunities and use that to fund the next stage of our technology development. So as we look back to phase one, right, that's been building neutron generators, neutron drivers, right? So how do we build those? Well, they're DD fusion and then eventually DT fusion drivers, right? And it's just simple beam target systems, right? So we've got a beam of ionized deuterium being shot down, either hitting a solid deuterium target, a gaseous deuterium target, or a gaseous tritium target. And that's used for a lot of different applications, right? Initially, it was used primarily for industrial applications, right? Neutron radiography or S&M detection, IED detection, narcotic detection, right? But as you go up to higher and higher fluxes, and certainly as you move into the world of DT fusion, you unlock a lot more opportunities, right? So kind of as we look at the culmination of where we've made it to in phase one, it's what we would call our flare system down in Janesville. It's a DT accelerator. It produces 5 times 10 to the 13 neutrons per second maximally. And currently we use that for a lot of material and electronics investigation for the Department of Defense. But it's a wonderful platform that we'd like to use for fusion material testing, right? We're very low on obviously displacements per atom. So as we talk about first wall, we're certainly nowhere in the ballpark of first wall, but we are able to look at testing, especially as we add, additional capabilities, testing things like superconducting magnets, right? Significantly more sensitive components as part of what would eventually be a fusion power plant. So that's really where we got our start in Shine. And then we positioned a little bit into how do we, again, keep pushing our fusion forward, our DT accelerators forward? What's a commercially viable opportunity for us there? And that pushed us into the medical isotope space. And so then we moved into how do I use something like a DT fusion generator to reduce our reliance on nuclear reactors worldwide for the production of medical isotopes, right? So a couple key medical isotopes that we focus on, molybdenum 99, iodine 131. We do that by using a DT accelerator that sits inside of a uranyl sulfate solution. So you're doing aqueous processing in real time for the separation of moly 99, iodine 131. You can also capture xenon. But it's another case where instead of moving to a full reactor, we have a subcritical reactor system driven by a high-powered DT accelerator. As we move into phase three, which is where we're really starting today, that's where we kind of get to engage with the energy market, right? Historically, we haven't engaged much with the energy market, but phase three, we're looking at the nuclear fission market, right? And that's a little bit interesting to talk about on a fusion call. But how are we going to interact with the fission market, right? In the US, we don't do fuel recycling. So step one is to get us to fuel recycling. But once you move past simple fuel recycling, what's the next step? Well, the next step is transmutation, right? We would like to take these long-lived isotopes, this raffinate that comes out of our nuclear fuel that's not useful for us, and we'd like to be able to turn it into something that doesn't live for millions of years, that doesn't produce significant amounts of heat, that we can store safely and effectively, right? And so again, by moving into, let's start with nuclear fuel recycling. It's something that's been proven. It's something that we can find commercial partnerships to move this forward. And as we move into that, then we get to take the next step to go, okay, now, how do I use very powerful fusion devices with very unique reactor designs? Right, we work with Professor Ben Lindley here on a number of fission fusion designs for fuel transmutation, and that really leads us to the final phase. Right, we're nowhere near it today, but the final phase is moving to fusion energy. Right, for Shine, our strategy has always been: what core competencies do we need to build in each stage that's going to allow us to reinvest in our technology, but also push forward in our fusion, journey and get to higher powered fusion devices, more stability, more understanding of how do we do tritium handling? How do we do nuclear construction? How do we go for an NRC Part 50 license for a public or for a private company today, right? And we were the first to do that in a long time. And so, there's all of these challenges that sit out in front of us. And we here as scientists love to focus on the technical challenges. What are the technical challenges stopping us from turning fusion energy into, a reality? But there's a lot of practical challenges that we've got to work through just in getting the US on board with moving forward with fusion energy, trying to use fusion energy to push fission energy forward. But certainly large capital nuclear construction is a place where, again, it's going to be a cornerstone of how we do uh, fusion energy. But it's something that, as startups, we don't have a lot of experience with. And it's a place where we would love to participate with the remaining community and find ways that we can use our expertise, what we've learned over the last several years, and really partner with, folks like Rialta and Type 1.
Great. Thank you very much. And I can't remember, did we go over your official title yet or no?
My title
Yes.
is very confusing. I'm in charge of R&D and our engineering and manufacturing teams.
All right. Fantastic. Chris, let's go to you next. What is your official title?
Oh, that's a really good question. My name is Chris Egna, so I have a complicated life. I'm a faculty member on campus, same department as Adele and Steffi. Long-standing relationship with UW. I've been here almost 35 years. So I started as a postdoc 1,000 years ago, and been a faculty member here for more than 2 decades. So I'm a co-founder of a company called Type 1 Energy. I started this company in about 2019 with my partners, which included David Anderson, who used to be a faculty member over in the electrical engineering department, and a guy named John Canick, who was a graduate of our department, came out of Dave Anderson's lab, and subsequently moved to Oak Ridge National Lab, where he was the head of a bunch of groups there. So Dave and John and I, with a couple other guys, formed a company called Type 1 Energy, built around the idea of advancing fusion energy to the point of commercialization using the concept called the stellarator. So the stellarator is I don't know if I want to get into technical details here, is a relatively complicated looking device. It's the basic premise of the stellarator is you design judiciously some complicated set of magnetic coils that are used to confine the plasma. So why did the company form? So the company formed because basically the World Stellar program had evolved to a very mature level. And we have proven at that point many of the problems that we need to overcome for a magnetic confinement device to work as a fusion reactor could be solved with the stellarator problem. So part of that came out of the University of Wisconsin. Dave Anderson led the lab led an experiment called the heliocentric experiment in the electrical engineering department. That experiment still exists. It's now run by Benedict Geiger, also a faculty member in my department, in electrical or nuclear engineering and engineering physics, I should say. But more prominently in the World Stellar program, there's a device called Wendelstein 7X, which was built in Germany, which was a billion-dollar, multi-billion-dollar class facility. Started operating in earnest 2017, 18, something like that. And very quickly we realized in the World program that it was going to meet its mission. It was going to really, demonstrate what it had advertised to demonstrate. So the moment was right. So the science had arrived. There were real no showstoppers for the stellarator. Simultaneously, there was the emergence of high temperature superconducting technology that came out of prominently MIT and also underpinned the emergence of a company called Commonwealth Fusion System, which was a spin out from MIT using a different technology called the tokamak, which we can talk about. Of course, I knew all those guys, I knew all those cats. So that technology emerged. It was also emerging areas in advanced manufacturing and new manufacturing technology. Also, my job is to do theoretical and computational modeling of plasmas. The devices that we were studying, HSX here on campus, and the Wendelstein device was designed in the 90s. So in the 30 years since that design, we've learned a hell of a lot of plasma physics. And so our codes have gotten way better. Our validation and verification techniques have really grown exponentially in the last couple of decades. So we could confidently not just use our theories to understand what's going on, but also make predictive understanding. And so one of the approaches we're using at our company is to use the advances of computational plasma physics to really make predictions. And so in lieu of building a bunch of devices and testing to see if they work, you do it all computationally first, and saving yourself lots of time and energy. So how did the company evolve? So we started the company in 2019. We applied, our first kind of foray was we really wanted to see if this new high temperature superconducting technology was going to work. So we applied for and won an RPE grant, similar and kin to was done by the mirror company Rialta. Got the name Rialta for a second there. Sorry about that. And then Dave Anderson led that effort. We partnered with our colleagues at Oak Ridge National Lab, MIT, Commonwealth Fusion Systems, and basically spent a couple years working that out and demonstrated that indeed worked. At that point, we emerged in 2022 saying we had the right technology, we had the right ideas, we had the right people, and started in earnest looking for investors. And so in the fall of 2022, we started attracting various folks, and we signed on with a company called Breakthrough Energy Ventures, which is a venture capital firm, was an arm of basically Bill Gates and partners. His partners are all people you would know, the names you would know. So in 2023, after landing our first seed money, a round of money, we started the company in earnest, and we grew from basically 3 of us to now we have over 140 employees. We have 4 offices, one in Boston, I should say, one in Oak Ridge, Tennessee, one in Vancouver, and one just a few blocks from here over on West Washington Avenue, the Madison office. So how this has evolved, and we've like I said, we've evolved the company rather significantly. We've grown not just by attracting lots of talent, so we've attracted lots of talents from the fusion community, and also other industries as well. That's been kind of a challenge, and one of our great reservoirs of strengths in the company right now is we've really collected a really good group of people. I'm very happy with the crowd we've collected. So the company's done very well. We attracted a new CEO in 2023, early 2023, named Chris Mowry, and he's been a tremendous raiser of money. And we announced a couple of months ago $82.4 million in additional seed money. So we're flush for a couple of years. Probably more prominently, we did a really important agreement. We reached agreement with an agreement with the Oak Ridge National Lab, the Tennessee Valley Authority, in the state of Tennessee. So TVA, for those who don't know, is, I don't know, the 5th largest utility in the company. The mechanism how this all worked out is TVA had shuttered a coal burning power plant before Christmas of last year, 2023. And the idea was we would be moving in, and they will be, that facility, that power plant facility, will be hosting our first device that we will be constructing. So the basic, so this is a very powerful approach, and we have a very partner-rich atmosphere. So the approach we call Fusion Direct, because we think it's the most direct, lowest risk path to realizing a fusion power plant. We want a fusion pilot plant. So we have a vision of doing this in a decadal time scale, and partnering with utility makes a heck of a lot of sense. A lot of good synergy there. We also partner. Now the company's 140 people, which sounds like a lot of people, but to do fusion, you're going to need a lot of help from not just people in your own company, but also coupling with folks in the public sector as well. So we have just an enormous number of partnerships with places like Oak Ridge National Lab, MIT, University of Wisconsin, Tennessee, UC San Diego, Texas, Maryland, Columbia, a bunch of other places like that, and a long list of industrial colleagues as well, working on various aspects. And we're trying to harness this into what we imagine will be a very successful project. So it's a very exciting time for us right now. This is we're at the very, as I said, we've collected a good chunk of seed round funding. So now we're under the gun to do some performance and do some reach some milestones, which we hope to do in short order, and that will, make folks more excited to invest in us. And we'd like to see this vision forward. So thank you.
Great. Thank you so much, Chris. And last but not least, we have Dominic. Is your title complicated?
Quite simple,
Okay,
actually,
fantastic.
yes. So I'm the Vice President of Technical Development at Realta Fusion. I'll talk a little bit about Realta's history, where we're at, where we're going. And as I do, you'll probably hear some themes. Some of those themes include emerging from publicly funded research through both university resources as well as federal resources as well. Another theme you'll hear, advances in technology, which have really made our concept viable. You'll hear themes about a lot of hard work that's been done by prior fusion companies, specifically along the regulatory front. You'll hear themes moving forward about desire for speed and desire for partnerships as well. There are a lot of different fusion energy concepts out there. The one common denominator, they're all really hard, right? And they're all quite capital intensive to deliver a fusion pilot plant and hopefully commercial power plants beyond that. So Real to Fusion is a pretty young company. We spun out of the University of Wisconsin a number of years ago, not unlike Type 1 Energy. And not unlike Type 1 Energy, we are one of 8 companies accepted into the flagship Department of Energy milestone-based fusion development program. We have closed a round of financing, a seed round of financing from Coastal Ventures, and we are really gaining traction moving forward. Realta's concept is a compact magnetic mirror fusion device that has been born from decades of publicly funded research. So we are applying modern advances to this decades of research to develop a system capable of delivering carbon-free energy to medium and large consumers of that energy. So the magnetic mirror was the leading concept in fusion research for a number of decades, up until the 1980s, when the oil crisis ended, the energy crisis ended, fusion budgets were slashed everywhere, and mirror research was largely mothballed, including the Phaedrus experiment right here at the University of Wisconsin. So internationally, research on mirrors continued, and Realta is reviving the concept and applying modern advances to it. So modern advances in high temperature superconducting materials, modern advances in plasma heating systems, and modern advances in high performance computing as well. So the resulting concept is a compact magnetic mirror fusion energy system that is appropriately scaled and appropriately sized for medium and large scale applications, whether delivering electricity to a data center or process heat to an industrial customer or a remote application, any other kind of off the grid or behind the meter application. That's really where we are in a position to shine. A couple other things about Real to Fusion. We are a Wisconsin-based company. So yes, we spun out of the University of Wisconsin, and we're deepening our roots and our ties to the University of Wisconsin by sponsoring research. So we sponsor research in the College of Engineering and the College of Letters and Sciences. We've got scientists and engineers working side by side with UW students and staff on the WAM experiment. That's that ARPA-E project that Realta spun from, just off campus at the Physical Sciences Lab. Moving forward, Realta is actively designing our prototype fusion energy system. We call it Anvil. And we're looking for a site to put that piece of equipment and to host our R&D headquarters. We'd love nothing more than for that device and that fusion energy campus to be right here in Wisconsin.
All right, great. Thank you very much. And what a sort of fantastic note to end the introductions on. So I think I'll like to start inviting any questions, both from the people in person and from folks online. And so you've seen, we have a diversity of perspectives here, but as Dominic pointed out, there are some common themes across these different companies and their experiences. So if are there any questions? Yep, sure.
So Randy asked, in the almost 40 years since I was a nuclear engineering student, commercial fusion has always been 10 years away. Are we at the point where that might actually be accurate?
Maybe the person who's been around the longest wants to comment. No disrespect, Chris.
So the short answer is yes. So I think we all are, I think there's a confluence of events that all allows us to make some significant predictions that we are going, there are a number of companies that are really making this pitch that on a decadal timescale, we'll start seeing fusion pilot plants emerging. I think the timing is right, the technology is right, the science has evolved, but probably more importantly, the political will is there. This is all driven largely by the problem we have with climate change and carbonization of our atmosphere. It's just there are people that know what's going on, realize we have to make a change with our energy portfolio. Fusion is going to be part of it. If we are to succeed and survive as a society, fusion will be part of the energy game. This is not to say fission and wind and all the other things will go away, but I think it's very clear that the timing is right. The events are arranged. And because we now have something like 45 companies in the world program, it's, the odds are there. There's money around. People are starting to take us seriously. And I think serious people are now running these companies, and somebody's going to make it.
Great, thank you. That's very inspiring. So I was actually going to throw over to Eli and say, Shine has been around doing various things for, quite a while now. So I was wondering if you could just reflect a little bit on sort of what your perspective has been like on this kind of perennial question of, is fusion just another 10 years away, and whether that's had any impact on what you've been doing.
So it's a good question. I don't think that's had a huge impact on what we've been doing. As like I said, our strategy has always been, when we started this, there was not the confluence that we're talking about, right? 15 years ago, we didn't have a confluence. We didn't have significant amounts of money coming from the government. We didn't have the U.S. and the world as a whole backing fusion and saying this is the way to go. And so our strategy had to adopt to, how do we keep the lights on, right? How do we get to keep doing this work? How do we get to advance this technology? So that's why I said, we're a bit of an odd company in playing here in that, fusion power, we see ourselves very much as, part of the team, and we want to help and we want to be there. But building a fusion power device is not something we will be doing in a decade, right? When we're talking about what we're focusing on in a decade, we're talking about transmutation, right, of long-lived nuclear waste. That's where we see ourselves in a decade. But we still see ourselves partnering with the fusion community, continuing to push our technology forward, and certainly being a test bed for things like breeding facilities, blanket facilities, tritium breeding, right? We have the ability to do that and to help the community in those ways. And so, I think as much as, fusion energy is the long goal that we really see, that obviously we see that as a sea change in the human experience right here on this planet. It's not necessarily exactly, we're not straight lining it, right? What was your term? Direct fusion? Yeah, fusion direct, right? I would call us fusion indirect is the way that I would describe Shine, right? And it's been great. There's a lot of great opportunities. We've learned a lot. We move the technology forward. Like Chris said, we build wonderful partnerships with universities all around the world and regulatory bodies. But it has been a slightly different path.
Yeah, fantastic. And I guess, Dominic, you mentioned this sort of in your overview. I guess mirror technologies have been on an interesting path. So has this, as a company that's focusing on something which was sort of set aside for a little while in the public research program, has this kind of recent change in events impacted you in any particular ways?
Right. So I think that Realta is riding the wave of current events, much like many of the other companies, right? We have the benefit of these decades of research, as well as the international investments that have been made in advancing similar concepts and also basic fusion science as well, right? So one of the reasons that we get to modernize the mirror, which used to use very complicated magnetic field shapes to manage the growth rate of certain plasma instabilities, happy to talk about that. We get to have a much simpler design because Russian research and Korean research and Japanese research have shown us different ways of stabilizing those plasmas. And because of those advances, we get to combine all those technologies and all that physics with the decades of research that have been done here in the United States to generate a new concept that has some really, really exciting attributes from an engineering standpoint and from an economic standpoint as well.
Okay, fantastic. Thank you. Yes, so we have a question from the audience.
So I'm just curious, is your deployment strategy that utilities would build utility scale plants for this, or are they also scalable for like industrial heat applications? So what's sort of the minimum size that you think this is going to work for?
Yeah, I think that's a great question. And I think that we would all have slightly different answers. I can speak for Realta Fusion. So we don't think about deployment yet, quite frankly. We're thinking about that first plant, right? That first fusion pilot plant. And our strategy is largely focused on speed. When we think about going super fast, we don't necessarily think about working with public utilities. We think about partnering with corporations or other entities that have a lot more control over their own domain. So data centers would be one example. We see models out there where new data centers are being asked to bring their own power because the grid can't quite keep up, or other considerations, right? So that could be a great partner. Process heat consumers. Fusion creates energy. 80% of it, in our case, in DT fusion, comes out as neutron heat. 20% we're going to capture as direct electricity. You can turn that heat into electricity. We can boil water and turn a turbine. That's not a problem. That's known engineering. We're really agnostic towards what you do with that energy. Our focus is finding a partner that's going to help us develop and de-risk that technology as fast as possible. And if we can do it one time, we will deploy wherever and whenever makes sense. That's our view.
Yeah, this is a long-term strategy question for us too, of course. And we took the first step. We found a utility. So it's going to be pretty easy for us to imagine putting our first facility at a utility because we are there already. So this is one of many ways. I mean, we're not closing the door to anything. Yeah, I think the world energy needs will change substantially. You know, the idea of Mr. Fusion, where you stick in the back of your car and go to work every day, that's not going to happen. These are going to be large, gigawatt-ish, hundreds of megawatt-ish level power plants, which will be for base load at, major cities around the country and the world. And I think that's our primary mission, our primary market.
Eli, was there anything you wanted to add?
No.
All right, fantastic. Yep, there's a hand up. Maybe someone could run the mics if that's okay. It's kind of a
Hi, my name is Scott Mosley. I'm the CEO of a startup accelerator here in town that's off campus. So I had a question about the ecosystem. And so one of the themes that I heard that you really didn't touch on was the first thing you did when you got funding was buy a plane ticket to Boston to go to, to all of you, to MIT, to the Engine, and to Commonwealth. So how do we change that dynamic to build a more robust ecosystem here for suppliers, for talent, for other things that could support the work that you're doing? How do we build that broader place so when people do get funding, they don't buy a ticket to Boston, they buy a ticket to Madison?
So we started with Boston. Yeah, I mean, again, this is a strategy question we talk about a lot in our company. How do we build up the ecosystem one of the things we're worrying about now is things like the talent pool for, generating people that we need to facilitate these things. I mean, one of the interesting kind of offshoots of this is we've talked to a variety of investors, some whom are interested in exactly this question. Like, how do I build not just, okay, you guys are going to go design the power plant that we're going to build, but all the stuff that goes around it, all the kind of accompanying technology needs to be developed. And so how do you seed that? So we're working with that investor community. The very interesting part of this is a lot of this, we do a lot of our talking to investors abroad in places like, South Korea, Japan, the Philippines, Vietnam, Australia, New Zealand, places that don't have a lot of natural resources, but they have smart people running these companies that recognize, hey, this is the energy of the future. We need to build up an industry around this. So the people, if you work with if you work with governments in the public-private sector, like we're talking about that, we imagine this is a world where that starts to occur. Now, it doesn't make sense to start a company now to do fusion services because we have produced 0 neutrons so far. So this is a hard thing to do. You have to create it out of thin air. But it is a strategy that we're talking about within our own company strategy sessions.
On that same point, one of the big challenges that we have right now is tritium expertise, right? There are very few centers of tritium expertise in the world. And so actually, Professor Diem, that was a place where we've been looking to partner with Professor Diem. And how do we make UW-Madison a tritium expertise, right? You've got Rochester and you've got a couple of other places. But if we're going to be a fusion center here in Madison, Wisconsin, then we need to reflect that in the university. And so, following up on that public and private partnership of how do we develop a training regimen and how do we then help fund that and help get that training into the UW?
Yeah, that's a really big question. When we would love to, have a conversation around that, a couple elements of that, right? So Realta is looking to stay in Wisconsin because we think that this is a good place to develop and deploy fusion machines from. As Chris pointed out, the United States is not a particularly attractive energy market. We've got a pile of natural gas at incredibly low cost, right? If you look at Singapore, Japan, Germany, and other markets, those are regions where energy is more expensive and might be more natural first deployments for fusion energy. But when we look at Wisconsin, what we see is one of the top 5, arguably the top fusion technology and fusion science institute in the United States, if not the world, right? That's an amazing talent pipeline. They have 3+ fusion machines on campus for training and for real research. That's incredible. We also have some really specialized manufacturing companies and talent, people who maybe have not yet been pulled into this emerging fusion ecosystem, but certainly should be and could help us deploy it. There are a number of potential power applications as well. I kind of glossed over the point. There's great diversity in fusion concepts, fusion energy concepts. And China has shown us that not all fusion technology needs to go towards energy generation. Our concept starts around 50 megawatts, maybe 100 megawatts. We see economies of scale going above that, up until 500-ish with our specific concept, and then we want to deploy in parallel. But there are a lot of, kind of low-grade process heat consumers, whether it's pulp and paper, or a number of the other industries in Wisconsin. So when we look at Wisconsin, we see a talent pipeline, we see a manufacturing base and manufacturing know-how, we see engineering know-how, and we see a market as well for some certain applications. What we haven't yet seen is one entity just draw all that together into a cohesive organization or unit, whether that's a regional authority or otherwise. Yeah, this is a great conversation. We would love to continue it.
Fantastic. So I think we had 2 questions. So we'll go one at the front and one at the back afterwards. Yeah.
Okay, thanks. Yeah, a very basic question. What are the differences or drawbacks with working with tritium versus working with deuterium in fusion processes? Thanks.
Tritium's a radioactive gas.
You should talk about this. Yes.
Yeah, tritium's a radioactive gas, right? And so it's very difficult to handle. It's also hydrogen, right? So remember, you can have lots and lots of pumps in the world that don't have permissivity to gas, and yet hydrogen still finds its way in, okay? So you're working with, the easiest, most permissible atom that is then flowing through while it's radioactive. And so it's really challenging, right? And it's challenging also because a lot of this right now is managed by the, DHS, right? The State Department here, they don't have a huge amount of experience with tritium, right? So you're trying to work on their ability to feel that you've done enough safety analysis that you're ready to do this work, without pushing it all the way to the NRC to say, okay, we're going to punt this. The NRC is going to be licensing your facility, right? So some facilities like the Chrysalis, we do want licensed by the NRC, right? Pursuing that Part 50. But for all of our work, we certainly don't want that, right? We want to be safe, but we want to be at a state level license where we can do R&D, where we can do experimentation, where we can do work. Does that answer your question? So when we look at our sites here in Fitchburg, actually, we only do deuterium fusion. We build our systems and we commission them on DD fusion, because then I don't need to license those facilities. Then we send them down to our tritium licensed facilities for full-scale testing.
Yeah. No, I don't think anything to add to that.
So I guess, was there another question now? Or if not, let's go to one online. There's someone behind us.
Yeah, so we have a question from Katie Carmody. What should or could state governments be doing to support the development of fusion technology, both in the commercial space and in interfacing with utilities in the near and long term?
No. Good question. I think there are a number of things that could be done. One of the really good things that I think the entire fusion community has prioritized is a clear regulatory framework that appropriately addresses the risks in a way that is not overly burdensome, right? We don't want to be lumped in with nuclear fission, right? In a one-size-fits-all approach. That will help us deploy more quickly and in a way that appropriately addresses the specific risks of any given concept. Because one of the things that we haven't discussed yet is that not all fusion concepts even burn the same fuel. I think we've got a lot of tritium expertise on stage with Shine, and thank you, Shine, for helping Wisconsin learn about tritium management. That's another leg in the Wisconsin story for fusion deployment. I believe the type 1 concept is a DT machine. We are pursuing a DT machine as well, although there are deuterium-only concepts and a number of other fuel sources. So regulatory framework is step one. Step two is to consider direct investment, whether it's in a facility itself or an organization or some sort of offtake agreement, right? So a lot of the fusion startup companies who are directing their efforts at fusion pilot plants and then deployment do have intermediate steps that are prototypes or that are pilot plants that will only serve the company for a brief moment in time, and thereafter will be available as a world-class research and development organization, right? So for Realta's case, our prototype device is called Anvil. By virtue of the fact that it hits all of our milestones, we're going to leave behind a giant neutron source, not unlike the SHINE system, but capable of incredibly high fluences, right? And the entire ecosystem, the fusion research community has been begging for such a device for decades, right? So can you imagine a situation where a state or the federal agency says, hey, when you're done with that, we'll take over running that? And maybe there's some sort of agreement that can help us move faster towards that very useful demonstration facility. A couple of ideas.
Well, there's an infinite number of ideas.
That's okay. I'm not sure I want to. I'm the tech guy. I don't know anything about politics.
I have a question about your financing. I know there have been like a couple of busts in investing in clean energy for the past 20 years, and but you seem pretty optimistic, even with interest rates so high, and you're like very capital intensive to find investors. That there are a lot floating around. I'm wondering why.
Well, I mean, we do have successes in this community. So the Commonwealth Fusion Systems raised $2 billion last year, 2 years ago, for whatever it was. So there's an appetite for this. So, we're talking about a fraction of the energy market of the planet. That's an enormous sum of money. So there's definitely appetite out there for this sort of thing. If we had a solution for the fusion problem, I think I think it's a pretty good bet that money would show up. And so, yeah, I'm a tech guy. I don't know anything about this politics stuff, but this is my understanding from talking to the investing community. If there's real solutions out there, the money will show up.
Yeah, real quick. So Ed Javier from WDC. So last year, the venture capital funds invested in Wisconsin was $490 million. All the VCs, 100 million of that went to fusion companies in Wisconsin. So when you think about all the industry that's happening in the startup world, there's a big bet for this area.
So before we jump to the next question, did anyone want to add anything to Chris?
I was just going to add some more color. I mean, so we're going after energy writ large, which today is tens of trillions of dollars, and that's before AI really takes off, quite frankly. And if you think about who is behind a lot of those data centers that are increasingly hundreds of megawatts pursuing gigawatts in scale, these are companies that have themselves made climate-friendly commitments. These are companies that need constant, always-on energy. That's really hard to do with wind and solar. It has a cost for grid firming like that. And these are companies that can deploy very quickly as well. So yes, raising capital is front of mind for every fusion developer. I think it's even for kind of the established companies for sure. And I would be shocked if we didn't see some sort of pruning over the coming years. Not all companies will make it. Maybe I'll be talking to Chris soon about getting a job. But yes, raising capital is really hard. Fusion is really capital intensive. We also, if there was a climate silver bullet, it might be fusion. There is no climate silver bullet, but if there was, it would look something like fusion.
Yeah, let me add a couple things. So as I said, there's something like 45, 50, I can't remember the number of fusion companies in the world. They're not all the same. They all have different ideas. Some of them are going to be bad. So some fusion companies will fail. Hopefully one will succeed.
Let's go to the question in the middle of the room.
Yeah. So my question is, this industry, the public-private partnership stuff you're doing, right? So there's two risks right now. There's a feasibility risk and there's an economics risk, right? Now, traditionally, like in Europe, if the public is driving it, governments are driving it, then they can address the feasibility risk first, and then there'll be offshoots of technology like you're talking about, neutron sources. When you go to private, right, and if private is driving it, like we're talking about investments, they want economics, right? They want economics, otherwise it's not going to fly. So your milestones are compounded now, correct? So so this is different from AI, for example. AI is going for feasibility. Who cares how much it costs? Then we'll bring the cost down. Technically, historically, that's been the pattern. But now this is is it a different experiment? Am I saying it this way? What do you guys think? Like, how are your milestones compounded? This.
Yeah, you have to find the right investors. So, you're not looking for quick buck guys that just I want the next quarter of profit. So you have to rank. And, the thing I didn't realize till we started a company is there's just an enormous variety of investors in the world. There's just a huge variety. There's the biggest charlatans you can imagine, and then there's, the biggest, benefactors, and you just you got to find the right niche. There's a lot of money out there in the investment community. You have to find the right people.
I would say what comes with that as well is who can represent you, right? Finding a banker that actually represents your company the way you want it to be and gets you those investors, right? So you're not looking for a 2-year investor, you're looking for a 10, 15, 20-year investor. And so it's a challenge, right? And you have times of drought through that. But, I think this is linked in a lot of ways to the previous question. If investors are willing to drop $2 billion, you should think that maybe they've got an inkling that something is worth investing in.
I'll just speak very briefly to what I see as a synergy between the public programs and the private programs as well. I think most people who follow fusion are at least vaguely familiar with the ITER project in the south of France. Very large scale, very complicated from an organizational standpoint. It's also been beset by a lot of delays. It's taking some time. It's not moving very quickly. What they are doing is moving very methodically, though. I think that for those who are following it, they've got a reasonable degree of confidence that when they get there, it's going to turn on and do what it said it's supposed to do. That's a different charter than what the startup community has. We have a concept that has risk. And to be clear, all fusion companies pursuing grid scale energy have a tremendous number of risks, including physics risks. Engineering risks, yes, and physics risks as well. So our job is not necessarily to push a snowplow that's 10 miles wide and try to address every risk along the way. It's really to zoom in on the crux of our challenge and to focus efforts on that question, which is a go or no go for our entire technology set. And if we hit that go, no go, and it's a no, our investors say, job well done. You've saved me X billions of dollars from investing in a dud technology, right? So it's a very different charter. Because of that difference in charter, we're capable of moving much, much faster. Commonwealth Fusion Systems is a great example, right? They're go, no go. Can you build a 20 Tesla toroidal field coil? They did. The bank opened up for them, and they've been able to move at breathtaking speed, right? So it's a very different thing. However, when Commonwealth Fusion gets to the system, when Commonwealth Fusion Systems gets to the point where they want to go beyond Spark to ARC, they're going to need the R&D that's coming out of the public programs to know what materials to put into that system, to understand how their fuel cycle is going to close itself, right? So I think that they're very synergistic, they're complementary, and they have different charters. That's my view.
So we've got two questions teed up. So firstly, the green jumper first. Thank you. And then after that, we'll probably have time for one more question. So if anyone wants to think of that while we have this discussion, please do.
I was introduced to fusion with the idea of helium-3, and now there's a lot of talk about fuel sources, but is that one that's even seems worth pursuing at this point?
So there are companies pursuing that approach, and I'll hand it off to Chris to talk about them.
No, you should talk about them.
Yeah, so that's on many companies' radars. I would say that. We think that our lowest risk path to commercial fusion at Realta is DT.
Great. So in the back there.
Yes, Chris, you talked about the need for finding talent. And I was wondering, as somebody who's not part of the fusion community, but has an interest in fusion and more broadly and interested in helping solving the climate problem, how can folks outside of the community help move this effort forward? And this is for anybody, but I know you mentioned.
Yeah. So listen, in order for us to go forward as a company, we don't need 100 PhDs or 100 new PhDs in, stellar physics. We've got the guys we need to do that. We need mechanical engineers. We need people to know, high vacuum technology, high field technology, electrical engineering, industrial engineering, all the standard things that you need to do. So if you've got a talent in those areas, we use them. And I think part of it is, if you work for, I don't know, to pick a company at random, let's say you work for John Deere, there's sort of a tried and true set of technologies you need to learn and master to be an accomplished, say, mechanical engineer at those companies. We don't actually know all the details of what our corporation is going to look like, what everything we'll need to master. We're learning it as we go. And so that's part of the fun and part of the challenge is to figure all that stuff out. So yeah, if you have a technical background and you have capability of solving problems, we'd be interested in hiring people like that. Yeah.
Yeah.
Go ahead.
I'll echo that, right? And probably 90% of my employees are not fusion experts. They've come in knowing very little about fusion. Some of them knew absolutely nothing about fusion, right? But then you get, people are on this journey with you and they're so excited to be a part of this technology moving forward, or, the steps that you make along the way. So I would say if you're excited, I mean, that's what we're looking for, right? We're looking for really talented, excited people who are passionate because it's hard work, right? I mean, the one unsaid thing is as you work at a startup, it's not like working at John Deere, right? It is really different, right? And failure is a routine part of your day in, day out. And that is hard to do. But if you find people with that level of resilience and passion for the work, you don't have to be an expert. There is 90% of the work we do does not require an expert.
Amen to that.
Okay, I guess, do we have maybe a question online? Yeah.
Piggybacking on the conversation on long-term strategy, Fusion has had major breakthroughs, but new tech often struggles because markets aren't ready. How are your teams testing and preparing for the market for the future you see?
Again, I'm a tech guy. I don't know. Well, listen, right. I mean, the market dictates exactly. This is sort of a kind of follow-on question to what was asked previously. So, I mean, we're relying on the fact that energy needs is only going to go up as we move forward. There's a blatant need to improve our technology portfolio in energy. So we're kind of relying on this. Yeah, is it possible the fusion game will just zero out in 5 years or 10 years or 15 years or something like that? Maybe, but it's better to take a leap than not, I guess.
Yeah, so I think that's for Realta, we are focused again on our first commercial pilot plant that we hope to place on a partner's site. So that approach, that strategy is one tactic to embed the voice of the customer directly in our organization. I'd say another tactic that we all have actually referenced up here today is ensuring that you have the appropriate partnerships. That includes your sponsors. So if you can bring potential customers along for the ride, get them in early, maybe even as investors in the company, you can ensure that you have a lens, the market's lens for what you're doing to ensure that when you arrive and say, ta-da, here we are, that somebody wants it and they're ready to accept it.
Eli, is there anything you wanted to add?
Yeah, I mean, we've had a little bit of a different strategy, right? Where we have had to kind of feel out the markets for each phase that we go through. And so it's been good and challenging in some ways, right? We sometimes, yeah, you think that you figured out the market and you're going to hit it at the right time and you're late or you're early or, there just wasn't the level of demand or there's too much demand. So we spend a lot of time trying to do forecasting and really understanding, okay, road mapping our technology. When do I need to get it from TRL 5 to 7, right? When does it actually need to be commercially viable? And then optimizing your efforts to go, okay, we won't invest in that until the day that I actually need to have it ready. So it's a big part of what we do, especially as we are, trying to be commercial along the way, commercialize our, business units as we establish them.
Fantastic. Just checking if there are any more online questions. Nope. All right. Anything from anyone in the room? Yep.
I'm kind of curious. So how do you think on the water fusion
Yeah, desal is a very energy intensive process, reverse osmosis and otherwise. And I think it's just when people reference fusion and desal, I think they're talking about an increasing need for clean potable water and the energy demands associated with that, and the potential for fusion to help fill that energy demand. Right. It's just where's your power coming from? Yeah.
Fantastic. And so I think we're sort of getting close to time, but I just want to leave a little bit of time for each of our panelists to give some kind of closing remarks or reflections. If there is one key takeaway for everyone in the audience from your respective companies, what would it be? Who wants to go first?
So I think one of the major things that you've heard today is a lot about partnership and a lot about a community here. And yes, we are separate entities, separate commercial entities. We all want to succeed. We all want to be commercially viable. But at the end of the day, we are all working toward a unified vision, which is fusion energy, right? Down the line. And so, I would say, regardless of what team you join, if it's something that you're interested in, if you're interested in the climate crisis, you want to get interested into a fusion technology startup, reach out, get involved, find ways to, there's lots of opportunities at our companies, at all of our companies. And so please, if you are interested, reach out.
Yeah, go ahead.
And I'll just build on that. I think another thing you heard today is just how hard fusion is still. And at Realta, when we think about hard problems, we think about putting as many ideas on the table to address those problems. And the more diverse perspectives you have, the more diverse your ideas, and the better chance you have to solve that problem. So we think a lot about building a pipeline, a talent pipeline, that is as diverse as possible, that has as much diversity of experience, life experience and career experience as well. So yes, I would encourage you, if you are fusion curious, to just get engaged. There are lots of different ways to get engaged. It doesn't have to be directly with a fusion developer directly. There are lots of ways through public policy. Fusion Industry Association is very good as well. Yeah, tell your friends. Fusion's great.
Well, let me just say, so I'm in a kind of neat perspective here because I have two jobs. So in one day job, my job is to, further the technical understanding of the plasma physics in a magnetic confinement facility and understand the deep underpinnings of what's going on. This is a time-consuming, it takes some, time-consuming process. It takes some deep thinking. It's a long, drawn-out process. You hire grad students, you teach them. They do work for 5 years on some really erudite problem. That's really still needed. In my other day job, we have problems. We show up in the morning and they need solutions in the afternoon. So I think the idea of having, we keep talking about this public-private partnership of that, we're going to need both. You're going to need the guys like our people in our company that have to come up with solutions immediately. And then there's going to be long-standing problems that still will need help from the broader public community that will need to enfranchise. Thanks.
Right. So yeah, so I think the big takeaway from everyone here is that, there are many, many, many different ways to get involved, and all involvement is helpful and very much welcome. And I think, everyone here is happy to entertain, further conversations on that. So I'd just like to go and thank each of the panelists for, volunteering their time this afternoon. And thank you all for attending. I know we've got a couple of minutes left for closing remarks. So I think I'll leave it there and hand it back over to our hosts.
All right, I just want to reiterate, thank you so much for coming out today. We hope to see you in October for our Latina Energy Leaders program. And thank you. Have a great rest of your evening.